Hey everyone, welcome back. This is me Anushka. Welcome to my channel. So today we are going to start VSEPR theory. So as the name suggests, VSEPR. So firstly we will know the full form of VSEPR. So VSEPR stand for valence shell electron pair repulsion theory. So basically, we know what is valence shell, right? The outermost shell of the atom is known as valence shell, and then the term come electron pair. So firstly, we will understand what is electron pair, right? I hope you all know what is bond pair and lone pair. Bond pair and lone pair. So bond pair are those electron which participate in bond formation, right? And lone pair are those electrons which do not participate in bond formation. Those valence electron which does not participate in bond formation are lone pair, and electron pair is the sum of bond pair and lone pair, right? So now we will understand how this theory come into existence, right? As we have earlier studied Lewis theory, and we know that there are many limitations of this theory, that this theory was unable to explain the shape of the molecule, right? Unable to explain the shape of the molecule. And if we doesn't know the shape of the molecule, so how does it works, right? So for this VSEPR theory comes, which explains the shape of the molecule. Basically it gives the basic idea about the shape of the molecule, right? For example, if I will talk about BeCl2, so how to find electron pair? Firstly, we will find electron pair because the shape of the molecule depends on electron pair, right? If the electron pairs are placed at maximum distance, so there must be a less repulsion between them, right? Repulsion is also there. So firstly we will find the electron pair, then we will place it at the maximum distance to reduce repulsion between them, and then the molecule will be stable. As we know that like charges repel each other, right? So electrons will repel each other because of same charge, so they must be placed at the maximum distance to reduce the repulsion, right? So what we will do, firstly we will find the electron pair of this central atom, right? So mm, we know that the valency of beryllium is 2, right? And we know that it is forming the bond with 2Cl, that it is completed, right? There is no lone pair in this molecule. There is no lone pair, right? So we will study about the chart, in which we will know that in how many lone pair and bond pair the what it will be the shape of the molecule. So it will come further on. So firstly, for example, I am giving here, right? We will place it like this, ClCl, and the angle between them is 180 degree, and this arrangement is known as linear, right? Shape of the molecule is linear, and we placed it like this so that the repulsion between the molecule is between the electron will be less, right? So firstly we will be discussing about the postulates of VSEPR theory, right? So number 1, The shape of the molecule depends upon the number of valence shell electron pairs, bonded pair and non-bonded pair, around the central atom. So I have already told you that the shape of the molecule depends upon the electron pair, right? I have already discussed it earlier, right? So this is first postulate. Then second one, pair of electrons in a valence shell repel one another since their electron clouds are negatively charged. So I have discussed it also that pair of electron, we know that electrons are of same charges, that is negatively charged, so they will repel each other. I have already discussed it, and I have also discussed this point again and again, that these pair of electron tends to occupy such a position in space that minimize repulsion and maximize distance between them. If two negatively charged particles are away from each other, so the repulsion between them will be less, right? So in the same way, to minimize repulsion, we have to maximize distance between them. This point, I hope it is clear. Then after, it is a point that multiple bond, we know that there are triple bond, double bond. So these bond will be considered as single electron pair, right? Then the repulsion interaction of electron pair decrease in the order, and this order is very important. For this you need to understand this order, that the repulsion between lone pair and lone pair is very maximum, means with it is very high, then lone pair bond pair and bond pair bond pair. The repulsion between bond pair is very less, and the repulsion between lone pair is very high, and it comes between lone pair and bond pair, right? This is the order which you have to remember. Then after, electron pair in a molecule occupy more space as compared to bond pair of electron. Why so? These molecules uh, occupy more space, because we have discussed that to minimize repulsion we have to maximize distance, right? If the distance between the means lone pair will be more, then the repulsion between them will be less, because we know that lone pair has maximum repulsion than bond pair and lone pair, right? So this is the reason behind it, that it requires more space, right? Then this repulsion effects result in deviation from idealized shape and alteration in bond angle, and because of this repulsion the shape of the molecule is changed, and there is also the change in bond angle, right? If there will be more repulsion between lone pair, so the angle between them is very less as compared to bond pair or lone pair bond pair. I hope it is clear. So now we are going to discuss about geometry and shape of the molecule with the help of lone pair and bond pair, right? So firstly we will take the examples. Suppose this is given and we have to find the geometry of this molecule. So if we will calculate the electron pair, so here 2 bond pair plus 0 lone pair, that means there will be 2 electron pair, right? So if number of electron pair is 2, then the geometry will be linear and the angle between the electron will be 180 degree. So we will place electrons atoms like this, and the angle between this is 180 degree, and this arrangement is known as linear arrangement. Okay, now let's take second example. So if we have given BF3, it is boron. So boron has valency of 3. That means 3 bond pair plus 0 lone pair. So 3 electron pair. If the number of electron pair are 3, then the arrangement is like this. Means angle between them is 120 degree and the geometry will be trigonal planar. So we will place central atom in between, then on 120 degree angle. Okay, so angle between this is 120 and this arrangement is called trigonal planar. Third example, CH4, 4 bond pair, 0 lone pair, 4 electron pair. If electron pair are 4, then the geometry will be tetrahedral and angle between them is 109.5. So we will place like this, such that the angle between them is 109.5 degree. Okay, I hope it's clear. Now let's take fourth example, PCl5. If we will calculate electron pair, 4 bond pair, 0 lone pair, and then 5 electron pair. If electron pair are 5, then the geometry will be trigonal bipyramidal like this, and the angle 90 degree and 120 degree are found. Let me tell you, like this it will form, and these angles are 120 degree and this are 90 degree. I hope it's clear. Another example, SF6. If we will calculate electron pair, 6 bond pair plus 0 lone pair, 6 electron pair. Here for 6 electron pair, geometry is octahedral and arrangement is like this, where the angle is 90 degree. So like this we will draw it like this, and angle between them is, both of them is 90 degree. I hope it's clear. Now we have discussed the case where there is 0 lone pair. Now we are discussing the case where the central ions having one or more lone pair. So let's discuss. So the geometry will be same. Geometry remains the same, but the shape of the molecule will be changed because of the presence of lone pair. Right? So let's discuss one by one. So we are taking SO2, right? So there are 2 bond pair and 1 lone pair, right? Then it will be 3 electron pair. So for 3 electron pair, the geometry remains the same. You have to remember it that for 3 electron pair, geometry is trigonal planar. For 3, if we will calculate it, it will be 3, and for 3 the geometry is trigonal planar. If there are 2 bond pair and 1 lone pair, then the shape of the molecule will be bent. So how we will draw it? We will draw it like this. Double bond, then 1 lone pair we will place here, and we will make its cloud. So this will be the shape, and we know that we are not, what its shape now? It look like V or bent. So you can say the shape of this molecule is bent or V shape, you can say. V shape. Okay. Now let's take another one. Suppose we are taking NH3. So here 3 bond pair plus 1 lone pair, that means 4 electron pair. For 4 electron pair, geometry will be tetrahedral. And what will be the shape of the molecule if there is one lone pair? So firstly, arrange these 3 hydrogen like this. And we will place lone pair here. So the shape of the molecule will be like this. And if we will not consider lone pair, so its shapes look like trigonal pyramidal. For 3 bond pair and 1 lone pair, the shape of the molecule will be trigonal pyramidal. See here also. I hope it's clear. Then let's take another example. Now we are taking H2O. Here 2 bond pair and 2 lone pair. Total 4 electron pair. For geometry will be tetrahedral. And shape. We will place oxygen here and hydrogen like this. And maximum distance between lone pair such that there is less repulsion like this. And if you will see, this shape is also bent or V shape. See, here also bent for 2 bond pair and 2 lone pair. Let's take another example. SF4. 4 bond pair plus 1 lone pair. There is 5 electron pair. And the geometry for 5 electron pair is trigonal bipyramidal. Right? Trigonal bipyramidal, and shape will be so. On this, these are called equatorial axes. So remember this thing, that lone pair are always placed on equatorial axis and these are axial. So here no electron pair is placed and we will place 1 electron pair here to minimize repulsion. So this, how it looks like? It looks like seesaw, though the shape of the molecule will be seesaw. See here. Then let's take another example. Now we are taking ClF3. So here 3 bond pair and 2 lone pair. That will be 5 electron pair. Geometry will be trigonal bipyramidal and shape will be for 5. We know that we place lone pair on equatorial axis. So we will place here lone pair, 2 lone pair, and other atom will be placed like this. So this will be its shape. I hope it's clear. Now let's take next example. BRF5. 7 5 bond pair one lone pair, 6 electron pair. Geometry will be octahedral. Octahedral. Sorry, we forgot to discuss its shape. So if you will see, then it looks like T shape, right? So its shape will be T shape. So octahedral, then we know that we make it like this. Like this. It's look like square. And here we place lone pair at these x's which are coming out, right? So place one electron pair here and another atom here. So if you will observe, it looks like it's not outside, it's inside. But for representation on 2D surface, we represent it like this. So it's look like square pyramidal. Square pyramidal. So shape is square pyramidal. Okay. See here, square pyramidal. Now let's take another example. ZEF, XeF4. So 4 bond pair, 2 lone pair, 6 electron pair. Geometry remains the same, that is octahedral, and shape will be like this. We know that N6 we place on these x's. So 2 lone pairs are placed like this, and F. If you will carefully observe it now, so it looks like square. It looks like square. So the shape is square planar. Shape is square planar. So this is all about VSEPR theory. I hope you understand it. Thank you.